Good morning, everyone. Welcome to Reduce, Reuse, Recycle, getting the most out of your LookML model. And to get started, we'll do a little interactiveness here. Raise your hand if you've been using Looker for more than 3 years. Maybe keep it up. How about longer than 2 years? Longer than 1 year? How about longer than 6 months? How about longer than 1 day? If you raised your hand at any point, this session is relevant for you. So we're going to be talking about getting the most out of your LookML model. As you grow Looker, as you add use cases, as you bring on more users, your Looker instance grows, and there are things that we can do to keep it under control. So whether you've been using Looker for a long time and are trying to wrangle things back, get them a little bit cleaner and crisper, or you're just building out, just getting started, these are some things you can keep in mind to keep things under control as you go forward. So we'll break it up into 3 sections. We'll talk about reusing code. So again, how can we reuse the code that we already have so we don't have to keep up to date and keep maintenance on duplicate code? How can we reduce the amount of code we have to begin with? So making sure that we keep it clean, only use what we need. And then recycle. So what are the things that we should be doing on a regular basis, cycling through to keep our instance clean and fresh? And this tech talk will be pretty technical. We'll be having code on stage, or code on the slides, things like that. These slides will be available after the conference, so we encourage you to take a look at them afterwards and really dig a little bit deeper if we go through them a little quickly here today. Just before we get started, a little bit about us, so why you should or maybe shouldn't listen to us in the first place. My name's Mike Slovich. I've been a professional services consultant here at Looker for a little over 2.5 years. I've been based in our Santa Cruz office, and I will be going to London, though, soon, so if any of you are here from Europe, looking forward to working with you when I get out there.
Thanks. Hi, everybody. I'm Maire Newton. I work with Mike on the professional services team. I'm actually based in our New York office, and I've been working with Looker for a little over a year now. And the first topic that we're going to dive into here is this idea of reuse. So how do we reuse code throughout our model in order to ensure that we're getting the sustainability of that model, the maintenance, and to help us with that? So to help with this concept, I'm going to talk about a use case that I run into with my customers on a regular basis. And that's this idea that we have different teams in our organization that have different needs when it comes to the data. So the example that I have up on the slides is something that comes up on a regular basis. And for example, we have in this slide an employees table, some sort of table in our database that has maybe some secure information. And we have different teams in the organization that need to utilize that data in a different way. In this case, we have a finance team, and maybe they're doing some balance sheet reporting, they're looking at general headcount costs. And so they need to access some of this information, the employee ID, maybe some salary information for that cost analysis. And then we also have a human resources team who's covering things like payroll and taxes. So they need access to everything that we have in our database. So how do we ensure that we can use this one table that we have with all of this information, and we can actually make sure that the right teams see the right data at the right time? There's a few different approaches that we can take. The first is this idea of creating maybe 2 different views. So we can connect to that underlying table, and we can expose different fields depending on which team is going to be accessing that view. And this is an approach that I see people who are a little bit newer to LookML, they tend to want to go this route. But there's a challenge here, which is that if you create 2 different views, you end up defining those shared fields multiple times. And anytime you're doing that, you leave room for discrepancies to come in. You could have changes that you need to make, and now you have to update that in 2 places. You start to lose that concept of having a single version of the truth. So that's never a good thing. The second approach we could take is this idea of using field sets. And field sets are a great feature in Looker. They're basically a way of taking a list of fields and creating a set out of them that can be reused throughout your model. So again, there's that reuse concept. And in this case, we could create a field set with all of those fields that our HR team should see, things like social security number that we really don't want anyone unnecessary accessing. But the challenge with this approach is that we have to then maintain this list. So if new fields start to come into our database, if we create any new dimensions or new measures, then we have to add those into our field set to ensure that our Explore is limited appropriately. And so that does add a little bit of a maintenance cost. And if we forget to add those fields to our field set, then it could potentially be a security risk as well. So the best approach from a best practices standpoint in Looker is actually to use something called a view extension. What on earth are extensions? Some of you may be using these already, and if you are, that's fantastic. But this is something that comes up all the time from our support team as one of the least used and least understood features in Looker, and yet I think it's probably one of the most important when it comes to model scalability. Extensions effectively give you ways of modularizing your code so that you can combine different LookML objects in different ways and then reuse that code throughout your model rather than redefining things. So you can basically set up these modules and then use them as building blocks in your model. Why would you want to use this extends concept? Well, at Looker, it's all about keeping your code dry, D-R-Y, which stands for do not repeat yourself. Don't repeat yourself. Again, it comes back to one version of the truth. Anytime you repeat yourself, there's chances for discrepancies and inconsistencies to come into your code set. It also makes it a lot easier to make changes because you're only referencing and creating objects in a single spot. So when you need to make changes, you can update it in one place. And that ensures that you have consistency throughout your entire model. So how would we go about applying this concept of extensions? And this is a look at what the code actually looks like behind the scenes. And as Mike mentioned, this will be available after. But over on the left-hand side, we have a basic employees view. And this is just accessing that underlying table in the database. And we're exposing the fields that are available to everybody. So in our situation that we're talking about here, that's our finance team and our HR team. Now, over on the right-hand side, we have an extended version of that view. And you can see the second line of code there says extends employees. So that's how we indicate that we're using this extension. And then what we do is we actually build the additional fields that we need, those additional content that we want to make available just to that subset of users, to that human resources team that we have. And this extend is effectively taking that original view that we had and then allowing us to continue to build on it and add in these additional fields. And you may notice down at the bottom, we do have a field that's defined twice. We have this total salary field. And you can see on one side, we have a different label than what's on the other side. And that's because extends also gives us the opportunity to redefine as we go, so that when we do have different needs for different user groups, we can make adjustments if we need to how some of those core files are being utilized. Now, let's dive a little bit deeper into what these extends are actually doing. So there's really 4 steps that are taking place anytime we're using an extends within our code. And those 4 steps are a copy step. So we copy whatever object we're extending. And then we merge that copy with the new code that we've written in that extension. And the reason we make that copy is because that original object, that's not going to be impacted by the fact that we're using an extend. The fact that we're extending it has no bearing on how that can be utilized. So we make that copy, and we do that merge. And anytime you're merging code, there is an opportunity for conflicts to come up. So the 3rd step is that we resolve those conflicts. We ensure that we end up with a set of code that can be interpreted just like any other LookML. And that's the 4th step, we finish. So we'll walk through each of these steps in detail so that you can actually see what's happening to those lines of code while we go. So the step 1, the copy step, really straightforward. We simply take that base view, that original view that we're looking at, and we make a copy of it. So all of the action here is taking place in that middle column, if you see on the slides. And then we take our new code set, and we merge that into the copy that we've created. So we have that extended view. This is a totally separate view that we're defining here. It's _ext to try to clarify that that's the extension. And we define those other fields, things like social security number, those fields that are personally identifiable that we only want limited access to. And that gets merged in with that copy that we've created. So anything that's net new, like social security number in this case, that gets added into our final result. And anything that's been redefined, like our measure label here, actually overwrites what we have in the copy. So we end up with a result that gives us our new view. Our net new fields get added in, so you can see those there in purple. And then the label for our total salary measure gets overwritten by the new label that we've supplied, which gives us two resulting views. One, a main employees view here that has just our three fields that everybody has access to. It's employee ID, salary, and our measure. Nothing personally identifiable there. And then our second view, that extended view, has those same fields. Our total salary was relabeled from employee cost to total salary. And then those personally identifiable fields were incorporated into that. And we didn't actually have to rewrite those fields out. This gets us part of the way there, because now we have two different views that we can work with, but we want to expose this to our end users, which means we need to build these into some sort of explorer so that users can actually query these views. So again, we have two different approaches that we could take. We could create two separate explorers, one that utilizes our base view and one that utilizes that extended view. But if any of those joins are the same, then we run into that same problem we had with views, which is that we're rewriting code and we're leaving room for discrepancies to come in. So just like with views, we can also extend explorers, and that's going to be the best approach that we want to take here. So to extend and explore, we're going to use a pretty similar methodology. Over on the left-hand side, you can see the code. We're in a main model file, so we have our connection specified, and we've built out a pretty basic explorer that's leveraging that main employees table that we have in our database. And the only difference that you may see here from explorers that you're used to is that we've defined a view name and a from parameter. So beyond just naming our explorer employees, we use that view name to specify what view we want to reference in our joins and for our end users. So in this case, it's redundant. It's still just that employees. And the from indicates what view we're pulling from, what view definition we want to use. And again, it's that base employees table. But we include these so that you can actually see how this changes once we do the extension. So over on the right-hand side, we have that extension logic. And you may notice that up at the very top, there's an include statement. And that's because this actually lives in a totally separate model from our original model, so that we can then apply model security to further ensure that the right groups have access to the right data. So we include our original model, and then we build out an advanced explorer and use that extends parameter again to extend that employees explorer and incorporate additional joins that we may need for our HR team. And beyond just incorporating those additional joins, we have our view name and our from specified again. And our view name here is staying the same. We still want to reference this as the employee's view. We want this to be seamless for our end users. We want our joins to still reference the employee's view. But our from is now pulling from that extension that we created. So that has all of our fields that we need for our HR team. So again, let's just walk through what's happening behind the scenes here. we're doing those same steps. Anytime you're using an extension, it's going to be these same steps taking place behind the scenes. The copy, the merge, the resolution of any conflicts, and then finally the finish, which is just your object getting interpreted like any other LookML object. So the copy step, just like before, we take that original Explore and we make a copy of it. We then merge that new code, that extended code, into that copy that we've made. And after we merge that code in, we resolve any conflicts that have come up. So in this case, the main conflict that we have is that from clause. Instead of pulling from that main employees Explore that everyone has access to, we're pulling from that extended version that has our full list of fields defined. And then any new code, those added joins that we had, those just get interpreted and added into that extended Explore. So the result is a base employees Explore, where we have just a few fields defined, and this is accessible to everybody, finance and our HR team. And then we have this advanced Explore that with model security and the extensions that we applied is only accessible to those HR users, that human resources department that needs that extra data, those personally identifiable fields. So this is a common example that we run across, this sort of security requirement. But this could also apply just for usability. So different users, maybe it's not security, but you don't want to overwhelm them with a bunch of fields that aren't relevant to them. So this same approach can be utilized strictly to ensure that users aren't overwhelmed when they're going into an Explore, and they have access just to the fields that they really care about. This concept isn't the only thing that you can do with extends. There's some other uses as well, and I'll touch on each of these briefly. The first is the idea of leveraging standardized content through the use of extends. So this might be partner blocks, or it could be something like Harthy announced yesterday, these new data blocks that are coming out, which are super cool. And the other topic is this idea of decentralizing your LookML development. So you may have a central team who's responsible for a lot of your core data, but maybe you have different departments and they're also interested in owning some of their own LookML logic. How can you enable that without risking those core metrics that you have? So I'll start by diving into this leveraging core libraries concept. And this applies to things like partner blocks or the data blocks that I mentioned. And in this case, I'll talk about our Google Analytics partner block. Google Analytics data is going to be pretty similar for everybody. That structure underneath is the same. So we have core files that you can bring in, you can connect to, and that actually defines your model and your views and pulls in all of that data. It does a lot of that legwork for you. But then by bringing that in and using extensions, you can infuse your own business logic on top of that and really leverage that work that's already been done so that you can get to that value faster. So here's an example of how you might do that. We have a core file up here, and this would never be edited. This is something that's maintained centrally, so you don't have to worry about the maintenance of this file. But then by bringing these into your project and extending them, you can infuse your own custom fields. You can bring in your own data sets and really work with this in whatever way you need to. So that's the idea here. And again, it would work the same way with those data blocks that we've announced at Join this week. Now, the second concept, this distributed LookML development, this also works the same way, but now instead of leveraging third-party blocks, we're talking about leveraging your own internal core files. So imagine you have centrally defined business logic that you need everybody to be utilizing, but you also want to give some freedom to different groups within your organization to do their own development, to play around, explore the data. But you can't compromise those core definitions that you have. You can do that as well. You can create your own project, your central project, with all of those key fields, key definitions, key KPIs. And then you can extend those. You can create projects with separate Git repositories specific to your different departments so that they can have that freedom to bring in that work that you're maintaining in a central place, and they can build from that. They can work from that in their own way. without compromising those central definitions that you do need to maintain in a standard way. And it's actually quite easy to get started with this. There's a newer feature in Looker called Project Import. If you're not familiar with it, check out your lab section of your admin panel, because there's a way of enabling this, and there's a ton of great documentation available. So if these sorts of scenarios apply to you, make sure to check that out, because it could really, really help with being able to leverage those sorts of core libraries that we have, those data blocks, or it could help you to create a hub and spoke type model for LookML development in your organization. So we've talked a lot about reuse, and reusing code is a great way to start to reduce the size of your model. But there's some other approaches that you can take as well to reduce your model and instance. So Mike is going to walk you through a few of those.
Awesome, thanks, Maire. Yep, so like Maire said, we talked about recycling, reusing code where we can. Reducing follows very closely on top of that. So you can think of this as where are there places where we don't need to add extra code. So there's a little bit of a reuse pattern here as well. We'll talk about a couple things. One is around making LookML a little bit dynamic, so talking about liquid parameters, user attributes, things like that. And then we'll also just talk about where maybe LookML logic can be moved outside of Looker and when that's appropriate. And lastly, we'll just talk a little bit about how to keep the code that's coming in, make sure that you're only putting in code that's reasonable, so reducing the amount of code that you put in. So to start, we're going to talk about dynamic table name injection. So the sort of use case here that we're going to talk about are tables with similar column structure. So this could be across schemas for schema partitioning. It could also be roll-up tables. So if you've got the same data, essentially rolled up at different granularities by date, by week, by month, et cetera. But the table structure is the same. You've got the same columns in each of those tables. So without table name injection, you're going to have to make a LookML view per aggregate table or per partition. So you're going to have a lot of views. Even though that logic is still the same, the model essentially would be the same because the column structure is the same. You're going to have to maintain those LookML views. However, with table name injection, we're going to be able to use just one LookML view per aggregate type or per just partition type or per table that exists in all the different partitions. The challenge with using this table name injection is finding the optimal table to use for a given query. Right? So if I'm using a roll-up table and I ask a question that I want to know by date, some information like that, I can't use a aggregation table that's rolled up by month, right? I don't have that level of granularity. So how can we dynamically keep track of that and just make it a really seamless use case for the end user? So here's our example. We've got a roll-up table, our events table. We've rolled it up to date, month, and year level. So similar column structure across all of these tables. Again, without sort of table name injection, we'd have to maintain a lot of views. And even on the front end, we'd have to join all those views in, so the user would have a lot of things to choose from. It would be, they'd have to know which view to pull from based on the granularity of data that they want for their query, which, I mean, let's be honest, our front-end users probably aren't going to want to do that, or literally might not even be able to do that. They might not understand what's going on there. Yep, and so with table name injection, we'll reduce the amount of code we need dramatically, and the front end will be seamless. End users won't need to understand anything that's going on behind the scenes. So again, sort of in the traditional world, without injecting table names, without just being able to have one LookML view that then injects the appropriate table, you'd have to maintain a view for your events, your raw data table. Then you could use events. You'd have to create another view for your events by date. Even with extends that Maire just explained so elegantly, you'd still have to maintain those two other views. So even though we're able to extend the events by date in the events by month and events by year views, you're still having to have all that additional code, which just obviously isn't ideal. So what can we do about that? Well, we can use dynamic table name injection. I've said that enough times by now. So you'll notice there in the code on the left, we've got one view that we've called events, and circled there in yellow at the top. We've got a little bit of code that's, essentially you can look at it. If you haven't used the liquid format, you can figure out pretty quickly. Liquid Parameters is a templating language that we can use sort of on top of LookML to customize queries even more. But you can see it's a pretty standard conditional block there, where depending on what the people or what the end users are using in their queries, we will dynamically select or inject the appropriate SQL table name. So we're using the liquid parameter in query here. So again, in query returns true if the field is included in the query itself. If you're filtering it, if it's involved anywhere in the explore context, that will return true. So in the example above, if the user has selected event ID, well, that's a row level, it's an event level piece of information. So we're going to need to use the raw data table. We're going to need to use the events table. However, if ID is not used, if the event time is not used, if the event date is not used, but we're filtering on month or we're grouping by month, we'll get down to that second to last row in that upper block, and we'll use the events by month table. Right? Why should we go ahead and query from the events table if we're just looking at aggregation by month? By using the events by month table, we're looking at a much smaller table. So if you're using something like Google BigQuery, you're scanning a much smaller number of rows, so it's literally going to be cheaper in the sense of dollars and cents. Or if you're using any other engine, it's going to be cheaper in computational cost, of course, right? Because you're scanning over less rows. So we're always using the smallest table we can to make sure we're actually getting accurate information, the smallest table we can to answer the question that the end user is constructing in the Explorer. And then you'll also notice that there at the bottom, we've just added a little extra code to adjust the measurement. So if you're using the raw events table, we'd need to do a count. Once you're using aggregations, we do a sum of total events. So in this case, we can just list it as a simple sum, where if we're using the event level table, we'll just do a sum of 1, which is essentially a count. And if we're using any of the aggregation tables, we'll just do a sum on the total events column. And so again here, we've taken what we had in the past as a lot more code, and just been able to consolidate it down to that one view on the left-hand side. And so not only is the actual code in the view files much smaller, it actually is everything's much easier in the models itself, so when you're defining the explorers, and also then on the front end when people are exploring in the explore section. So you'll notice on the left-hand side, if you had all of those event aggregation views, you'd have to join each one in individually or explore them each individually. And again, in the Explore picker down there at the bottom, you'd have a lot of explorers. The users would have to know which Explorer to go to start. Or if they went to the larger Explorer that you had everything joined into, they'd have this large list of fields on the left-hand side in the field picker. And again, they would have to know the right view to go to based on their query. Because if somebody is trying to group by date and selects total events by year, that's not going to be good. So that requires a level of knowledge for end users that honestly in most cases just isn't reasonable to expect. So we very often would just have to stick with that lowest level of granularity table, the events table, and that can just be a lot more computationally expensive or dollars and cents expensive. And again, with that liquid block and the dynamic table name injection, the Explore menu now has one very simple Explore, very easy. Nobody's going to go to the wrong Explore there. And again, in the field picker, when you're actually exploring, very simple. You just pick date, month, year, whatever it is, and behind the scenes, the appropriate table gets selected for you. So we can just take a look here at 3 example queries that I've constructed from that simplified Explore. So in the upper left, it's just selected there. It might be hard to see, but I've just selected total events, the measure. And you'll notice, circled in blue there, we've selected the events by year table to select from, right? We're just doing a sum of all events, so we don't need to look at it at any more granularity than sort of the most rolled up to begin with. Moving down on the bottom left, I've selected to group by date in this case. So I've added the date group by in there. And now we've seen that the select from has changed to events by date, right? I'm now trying to group by date. I need to use a more granular table. And again, that just happened dynamically. The end user didn't need to understand anything about that. And lastly, if I go ahead and I select event time, now we need to look at the event level data. So not only are we selecting from the events table, we're also using that slightly augmented measure there, where we're doing the sum of 1, essentially, as a step in for count. So that's how we can use dynamic table name injection for that roll-up aggregate situation. Sometimes we use the term aggregate awareness. That's a phrase you might start hearing more and more as this becomes more common. The idea of Looker is aware of what aggregation level to use. So that's one of those places where LookML has solved this sort of larger problem that a lot of people have been struggling with for a long time. Another use case here for dynamic injection is for schemas. So you might imagine in this case, we've got similar table structure across multiple schemas. So in this case, we've got a users, orders, events, and sessions table. But I've broken that out across schemas. So maybe across customers, I want to keep my customer data separate. Just keep everything nice and separated. So we've got customer A schema, customer B schema, customer C schema, and they've got the exact same tables inside. Obviously different data, but the exact same structure. So without dynamically injecting schema name, we'd have to create LookML views for each one of those tables. So we'd literally have to make, essentially in this specific example with just 3 schemas, we'd have to make, 12 views. That's not awesome. And obviously, you'd have a lot more tables and a lot more schemas likely, just not going to scale, not any good. So what can we do about that? We can dynamically inject the schema name using user attributes and, again, liquid parameters, or liquid templating. So again, with Liquid, we can sort of pluck things from other parts of the Looker instance, whether it's things that people have done in the UI or other settings, and set them into the SQL that Looker is generating. So here we're leveraging user attributes. Margaret talked about this during the keynote speak this morning. So for a given user, you can set a specific parameter for them. You can set a specific setting for each user. It can be different for each user, and it will show up when that user runs a query. So in this case, for users, I've created this custom schema user attribute, and then we can assign a custom schema per user. So in this case, down there on the bottom right, I've assigned my user the custom schema name customer A. Again, you would set that dynamically, and it would inject the appropriate schema into the query at runtime. So when I come back and I put all this together and look at what the LookML looks like, rather than having to make a different view for every table in every schema, I can just say for each table, create my view. In this case, I've selected the events view again. In that SQL table name, I've done something similar to what I talked about earlier with the table name injection. But here I'm using liquid parameters in that user attributes function there. Again, pull out the custom schema for me or for whoever's running the query, and then go ahead and inject that in as the table name. So in this case, you can see there at the bottom, in the actual Explorer itself, when I select count, we go ahead and Looker constructs the query, and in the from clause there at the bottom, we're doing the customer A schema.events. If Maire had been set up to use customer B, we'd see customer B events there. So again, you're creating one view, and then just assigning schemas to the users as appropriate. So user A will always come in and see schema A. User B will always come in and see schema B. But we can model out the table the same, because really the table is just one entity, and it should only really have one model. We shouldn't have multiple models modeling the exact same logic. So this is one way where we can reduce the amount of code we need, because we're able to just dynamically put in the appropriate parameters. So if you haven't used Liquid, if you haven't used user attributes a lot, highly encourage you to take a look at it, get the slides afterwards, take a peek, look at the docs. They're really powerful. So a couple other things we can talk about around reducing code. So when and where to use PDTs. So again, as instances grow, as you add use cases, things like that, you can start to add more and more derived tables, Looker-derived tables. Again, we talked about native derived tables and things like that this morning. But at certain points, there are times when that code should live in Looker, and when that code maybe should live outside of Looker. Maybe LookML isn't the best place to be defining that. It's really nice to use derived tables in LookML for fast iteration, right? You don't have to go anywhere else. You can edit it right there. You can do it in development mode. You're not making any changes to production. It's really great for fast iteration. However, once you've got that set, you've rolled it out to users, it's probably not going to change that often. There's sometimes value there in maybe moving that out to the ETL process. The nice things about moving it out to the ETL process is that First of all, you can use things like incremental loading and other database optimization techniques. It makes it a little bit more robust. Nobody's going to actually go in and edit the LookML because you have to go to a separate place to actually change that. So if it's in production, maybe you want it somewhere that's a little bit harder to accidentally edit. Obviously, the downside of that is you have to go somewhere else to edit it. Makes the iteration process a little slower. And so the last thing I want to talk about here is just keeping code clean. Just a couple suggestions here. In your LookML projects, you can set up the project settings for code quality review, and if you use GitHub, pull requests. So very, very, very much want to recommend checking code quality, require LookML validation to commit, right? We don't want anybody committing bad code. There's no need for that. That's just going to add to your instance. It's going to make it bloat, right? There's no reason to be committing bad code. Let's reduce that. And also, if you use GitHub, definitely set up pull requests, do code review. As instances grow, maybe you're the only person editing LookML for your company. Hopefully you grow, and that will no longer be the case, right? If things go well, that will no longer be the case. So once you start to have multiple people committing LookML, deploying LookML to production, you really need to have people reviewing that, making sure everybody's on the same page about what's going in, making sure that somebody isn't committing code that really somebody else already made that does the same thing. This is something that collaborators and software engineers already do, right? They are, like Daniel Min said it this morning, they already knew the whole Git thing. Pull request is just, everybody does it. It's just part of the process, and it should become the same thing for you and your analytics development process as well, your LookML development process. So that covers reducing. So Maire's going to wrap it up here, talk a little bit about recycling, and then we'll have time for some questions, hopefully.
Thanks, Mike. So when it comes to recycling, that's all about sustainability. How do you ensure that you can keep your model clean over time? And so we'll just briefly touch on a few items here. And the first is to make sure that you're reviewing your code, like Mike was saying, and reviewing your LookML on a regular basis. We've talked about a few different approaches, different tactics that you can take today to reduce and reuse the code that you already have. And it would be fantastic if you're able to go back and implement some of that right now. But it shouldn't be a one-and-done thing. Try to set up a regular cadence where you're actually looking and reviewing what you have, looking for opportunities to streamline your code and introduce extends, introduce things like SQL injection. And alongside that, read the release notes, because something like SQL injection, that's new. So if you're not keeping on top of those release notes and seeing what's coming out in the new releases of Looker, you could be missing out on some of those opportunities. So please take the time to read those release notes. And if you have questions on what you see or are curious about how this might apply to you, reach out to us. We're always happy to help. Along with the release notes, keep on top of the labs and legacy section in your admin panel. Because sometimes those new features, they may still be in beta. You may need to enable those. So if there's things that you're interested in enabling, check out the lab section and turn those new features on. Start using them as soon as you can. And then give us any feedback that you have. And similarly, disable legacy features as quickly as you can so that you're not stuck using things that are going to be deprecated over time. And last but not least, for those of you that are hosting Looker yourself, make sure that you upgrade. Because we've got a ton of great stuff coming down the line. For those of you in the keynote this morning, you know that there's a ton of new features that are about to become available. And if you're not upgrading on a regular cadence, then you could be missing out on some of those opportunities as well. So make sure that you upgrade as frequently as you can.